The Cyrillic Projector was originally a piece displayed in James Sanborn's gallery shows in the early 1990s. In 1997, it was installed permanently at the University of North Carolina, Charlotte. Another Sanborn sculpture, the Adam Smith spinning top, is installed across from it. Sanborn is the artist most famous for Kryptos, another coded sculpture installed inside the CIA headquarters in Langley, Virginia. Sanborn has sculptures all over the United States, the majority of which are full of cryptographic messages. So far, only 3/4 of Kryptos has been decrypted. The last section remains a mystery more than 19 years later. Kryptos fanatics are always looking for clues in Sanborn's other sculptures because some of them are actually related. The Cyrillic Projector is a bronze cylinder 5 feet wide and 8 feet tall with hundreds of Cyrillic characters cut through its metal circumference. The letters are carved into the sculpture inside out, so they appear reversed from the outside. At night, a bright light on the inside of the cylinder shines through the letters, illuminating the campus courtyard with encrypted Cyrillic text. And since the letters were carved inside out, when it projects the text onto the courtyard, the text is projected correctly. The Cyrillic Projector sculpture is divided vertically into 2 pages, a cipher page of encoded text and a Vigenère square page. The Cyrillic Projector uses the Cyrillic alphabet, obviously, although Sanborn has made 2 changes to his Cyrillic alphabet. The umlaut E is not used, and the Cyrillic W has been moved to a different position. The first step in decrypting the Cyrillic Projector was transcribing the text from the sculpture. A complete transcript was compiled in June 2003. It took several weeks for members of the Kryptos group to transcribe the Cyrillic characters from photographs into 3 independent transcripts. Those 3 transcripts were then compared and compiled to try and ensure as much accuracy as possible. This compiled transcript was posted online. Let's take a look at this text. Panel 1. The English word Medusa is embedded in the encrypted text. There are no Cyrillic characters for the letters D, U, or S. Although there are characters that make those sounds, the letters are not used anywhere else on the sculpture. The importance of this word is highlighted by the fact of an extra hidden bolt centered on this line, but it is only visible from the inside. Here is panel 2. Panel 3 is the first half of the Vigenère square, using the keyword TEHB, which is Russian for shade, shadow, very appropriate for a sculpture that displays text through light and shadows. This also hints that the plain text will be in Russian. Panel 4 is the second half of the Vigenère square. Now let's talk about how this code was cracked. Once the transcript was posted online, anyone could try their hand at cracking the code. One independent cryptographer figured out a decryption method in July of 2003, but was unable to finish because his decryption resulted in a solid wall of Russian text. First, let's look at how he cracked the code. It's as easy as 1, 2, 3. Even though there was a Vigenère square on the sculpture, no one was absolutely sure that the message had been encoded using Vigenère. So first, we compare frequency distributions for portions of the text, like the first 80 characters versus the second 80 characters versus the third. Then, the first 240 characters versus the second 240. If they look about the same, then it's probably not a multi-cipher identity, like Kryptos. Next, we use the Kosinski Method to try and determine the length of the Vigenère keyword. First, we start by looking for repeated sequences. There are a lot of them, and some of them are surprisingly long, some up to 12 characters. This is further confirmation that this is a Vigenère type system. Now we count the spaces between the repeated sequences. 114 spaces, 210 spaces, 180, 372. All of these are divisible by 6. From this we can work out that the keyword is likely 6 characters long. Now that we have a keyword length, we can divide up the ciphertext into 6 sections. We take the first character, the 6th character, the 12th character, and so on. Then we take the 2nd, the 7th, the 13th. We divide it up into 6 ciphertexts. Now we can perform frequency analysis on each of these 6 sections of ciphertext, using Russian character frequency, of course. Given the large amount of ciphertext supplied, the distributions are very well formed and after careful study align quite readily with Russian character frequency analysis. As it turns out, the key word used to encrypt the message is actually that clue word Medusa, encrypted with a double vigenère. First, we translate the non-Cyrillic characters in Medusa, D, U, and S, into their phonetically matched Cyrillic characters. We then take that key word and line it up on the vigenère square to get our 6 cipher alphabets, giving us that final key word. Once you've determined the key word and have the 6 cipher alphabets, you can decipher the entire message. We decrypt each section of ciphertext using the correct line of the vigenère square. Once we've got it decrypted, then we combine the 6 ciphertexts back into one block of text. However, as you can see, we now have that solid wall of Russian plaintext with no spaces and no punctuation. If the deciphered message had been in English, it would have been fairly easy to complete the decryption because you could distinguish words. This sentence might be easily understandable to a native English speaker, but someone not familiar with English would have a great deal of trouble. Without knowing Russian, it was impossible. Online translation programs were of little use because the resulting text was all run together and included numerous intentional spelling errors and missing letters. This added even further to the complexity of working out the correct Russian plaintext. The Kryptos group had invited Russian translators into their group, and so they were able to separate the words out and continue on with the decryption. Once the Russian plaintext was worked out, they then began the process of actually translating the message into English and trying to work out the original source of the text. The message on the Cyrillic projector has turned out to be in 2 parts. The decrypted first part is a Russian text encouraging secret agents to psychologically control potential sources of information. The second part is a partial quote from a classified KGB correspondence about the Soviet dissident Sakharov, with concerns that his report to the Pugwash Conference was being used by the Americans for an anti-Soviet agenda. So, in September 2003, 7 years after its installation on the UNCC campus, the Cyrillic projector code was decrypted.